In this video, we're going to cover the 5-number summary in box plots. And there's a few different definitions we have here in this first box here that we need to cover. So one of them is the median, which is supposed to represent approximately the 50th percentile of the data set. So is what we will do to find the median is we will find the 50th percentile. Okay. The median is used to locate the center of our data. Let's go ahead and highlight that. Now, the mean and the standard deviation were better for symmetric or approximately symmetric distributions that didn't have outliers. Okay. And so now if we have data, with outliers or that are skewed, our better option here might be the median. And the purpose of, or the reason for this is the median isn't affected by extreme observations or outliers, while the mean and actually the standard deviation and variance are heavily influenced by outliers. Okay. And we'll also have another measure of spread here, which we'll call the interquartile range, which we'll talk about here in a little bit. And the interquartile range will also be a resistant measure of center, and it'll be why we'll prefer to measure our spread using the interquartile range when our data is, again, not symmetric or maybe it has some outliers. So then we have our quartiles. Okay. And so our quartiles are sometimes, let's look at one of them first. The first quartile, which we'll often denote with Q1, is the 25th percentile. Okay. And Q3, the third quartile, is the 75th percentile. Sometimes this first quartile is called the lower quartile, and sometimes the third quartile is called the upper quartile. But in other words, the first quartile marks the spot in our data set such that the first quartile marks the spot such that 25% of the data is at that spot or below. Okay. The third quartile marks the spot such that 75% of the data is at that spot or below. And then we have our 5-number summary, so when we were talking about symmetric distributions, and specifically the normal distribution, there were only really 2 numbers that we needed to describe the distribution, and that was the mean and the standard deviation. Okay. Now, when our data is not symmetric and has outliers, we might need a few more numbers to describe the distribution in detail. And those 5 numbers here are going to be the minimum, the first quartile, the median, the third quartile, and the maximum. And we will have a visual representation of this, and we'll call it a box plot, or sometimes called a box and whisker plot. And so here's a picture of one, and is what we can kind of see here is at the lower end, we'll have the minimum marked. Okay. At the upper end, we'll have the maximum marked over here. Sometimes a vertical bar is put here like you see in this one, but sometimes there's nothing there. Sometimes they'll leave this vertical bar off is what I'm trying to say. And sometimes they'll just put a dot here. So you will see different styles for the minimum and maximum in box plots. Okay. However, the middle part will be the same no matter what. And by middle part, I mean this will mark the first quartile, the left end of the box. The median will be the line in between the lower and upper quartile in the box. And then lastly, the third quartile will be the right end of the box. All right. And I also want to point out, since 25% of the data is here and below, and the median 50% is here and below, and for the third quartile, 75% of the data is here and below. Let me kind of mark that. Is what that really means is in every single one of these quartiles, or let me be a little bit more specific. In each one of these quarters, we have 25% of the data. And I kind of want to mark that neatly here. So here is going to be 25% of the data. Maybe I'll mark these in different colors so that we can tell that they're different intervals. I want to scoot that down here. There we go. So another 25% in here. And so in this picture, um, the two whiskers are about the same length, and the distance between the first quartile and the median and the third quartile and the median look about the same. But this isn't always going to be the case. And that's why I'm trying to emphasize that each one of these areas here represent 25% of the data. Let me add one last one. Here we go. All right, well, let's go ahead and scoot down and we'll try an example. We'll come up with a 5-number summary and we will make a box plot. So here we have a medical experiment involving 72 guinea pigs. We've seen this example before. They had been infected with an infectious bacteria, and it was observed how many days they survived. Okay. And so in part A, we're being asked to find the 5-number summary. So we're in luck. This is a data set that I would not want to put in order. And luckily for us, somebody has already put it in order, so we don't have to worry about that. But that is technically something you would need to do if you were coming up with the 5-number summary by hand, is you'd have to order the data. Okay. So let's start off by maybe writing the easiest options here. So in our 5-number summary, we will have a minimum and we'll have a maximum. Okay, and because this is an order, I know that this is my minimum. And I know that this is my maximum over here, 598. Okay, we're also going to have a median that we're going to need to find. And so to find the median, remember this is supposed to be the 50th percentile. And we have a nice little formula for this, right? We were using L, the location of the median, should be equal to N, which is the number of observations or data values that we have here. So we have 72 of those. So I'm going to write in a 72 here. And then we want to multiply this by P over 100. And since we're talking about the median, this is the 50th percentile. So 50 out of 100 here. And so let's go ahead and do 72 times 50 over 100. Or if you don't want to write 50 over 100, we could have just written 0.5 in place of it. So we're getting 36. So this means, since we got a whole number, that we want to actually average the 36th and 37th number. So average 35th and 36th. Sorry, 36th and 37th numbers in our ordered data set. So let's go see if we can find those. Okay. So I would just note that these rows here have 12 numbers in them. Okay. So this would be our 12th number. This is the 24th number. This is the 36th. So what this means is to find our median, we're going to take this number here, number 36 and number 37. We're going to average those. So 102 plus 103 divided by 2. And so that's going to give us 102.5. Let me see if I can shrink up this fraction here a little bit so it takes up a little less space. Yeah. And I wanted a little more space because I'm going to want to fit in here our first quartile, which I'm just going to write as Q1, and then our third quartile, Q3. So this time for Q1, we would like to find the location again. We have 72 numbers in this data set, and we want to find the 25th percentile. So I want to take a quarter of 72 now. And I get a whole number again, which means I'm going to have to average the 18th and 19th number. Let's just verify that again. Yeah, 18. And so we'll go ahead and we'll go over here and we'll count. So let's see here. This is the 12th number here. So then I have 13, 14, 15, 16, 17, 18 right here. Okay. So this right here is 18 and 19. So we just want to average those. And that's just going to give us an 82.5 if we average those. All right. Then next, we can go ahead and we can find Q3, okay, the third quartile, or in other words, we're going to find the 75th percentile. So let's go ahead and write that in. L equals 72 times 75 over 100, or just 72 times 0.75. And so here I'm getting 54. So once again, this is a whole number. So I'm going to want to average the 54th and 55th number in our ordered list. Okay. So that means I need to go a little further down here. So this is the 48th number. This would be the 60th number. And so what? Again, I want the 54th. So let's say that this is 48 here. So then we have 49, 50, 51, 52, 53, and then finally 54 right here. So this is 54, this is 55. And so I just need to average those two numbers. So 147 and 156. 147 plus 156. Just double checking here. And then to average them, I want to add them and divide by 2. So 151.5. All right, and so now is what we're going to do is we're going to display this data in a box plot, and we have values that vary from 43 up to 598. I think we're going to want to count by hundreds here maybe. I might add in the 50s as well, but so yeah, maybe we'll count by 50s, but let's see here. So what I'm going to start off with is just making a number line. And this number line might be longer than it needs to be. We'll see. And I'm going to try to equally space some tick marks here. A ruler would definitely be helpful here. But let's call this 0, 100, 200, 300, 400, 500. And then again, we don't have anything bigger than 600, so I'll end it at 600. Right, there we go. That should be plenty to make our box plot. Okay. All right. And if we do want to add in the 50s here, we could just add in a little tick mark here for halfway in between to give us a reference. Okay. There we go. So is what I do is I start off with the minimum, the very first number, and I'm going to make a vertical bar actually for all 5 of these numbers here. So for the 43, I'm going to do my best to identify where that would be. So 43, that's roughly right here. I was debating whether I wanted to move that over a little more, but we're just doing our best here. And then 82.5 for Q1. So 80, I'm going to guess that that is somewhere right in here. Need to see if I can scoot that up a little bit so that it's in line with our other one. There we go. All right. And then for the median, which is 102.5, 102. So that's just barely past the 100 mark. There we go. And then we have 151, so just barely past 150. And then 598, which is way out here. 598. So that's going to be just short of the 600. So is what you do is you actually put a box around Q1, Q3 in the median here. And then you're going to draw a line all the way out to the max and the min from the box. Okay. And this does show us something here. It may not be clear right off the bat, but this is actually skewed to the right. So remember, there's 25% of the data from here to here, 25% from here to here, 25% from here to here, and then lastly 25% from here to here. So that last 25% is really spread out. Like this side is going to be the tail. And right here we have 50% of the data crammed into this one spot. Okay? Or you could say 75% crammed in right here. So if we were to imagine what this would look like, I'm going to have to make it much smaller so that we can see it. Is I would expect, again, all the data piled up here at the beginning. And then that last 25%, let me see if I can do that a little bit better. 5% here in the tail. Okay. That's the idea. Okay. So I am going to just note here that, yeah, this is skewed to the right because our tail's to the right. And so then we're asked, well, what do you expect? Is the mean or the median going to be larger here? And when it's skewed like this, remember the mean gets pulled towards the tail. So that means our mean is going to be bigger here. And we expect this again because it's skewed right. Okay. So we will eventually actually compare some histograms to some box plots so you can kind of observe this skewness a little bit easier. Okay. But we'll save that for a couple examples further down. Right. So here's another one that we're going to create the 5 number summary and display a box plot. And this time our data has actually not been given to us in a list. It's instead been given to us using a frequency table. Okay. And so this is kind of a strange study, but it says a study of freely forming groups in bars throughout Europe examined the total number of individuals found in groups whose members were laughing together. The study reported a total of 501 laughing groups distributed as follows. And it says in this table, we have the number of individual groups and the number of groups. So that means that there were 254 groups of size 2 that were laughing together. Okay. Similarly, they also found 168 groups that had 3 people in them where they were all laughing together, and so on. Okay. Now, I left a little bit of space here because it's going to end up that it's going to be helpful to look at the cumulative frequency, which we'll do here in a moment. But let's just start off with the easy stuff, the minimum and the maximum. Okay. So I do want to point out though that this right here is our frequency. So 254 is not a number in our data set. It's telling us that there are 254 twos. Okay. So what this means though is the smallest group where people were laughing together was 2. And this is because this is the smallest group of people, plural, that we could have. Any less and it would be singular. We'd just have one person and it wouldn't be a group. So is what we'll put down here is that we already know our minimum. Let's do that. And we should be able to find our maximum pretty easily here too if we move up. So the biggest group where they found everyone laughing together was a group of 6. And in fact, they found 6 groups of 6 where this was happening. But 6 is our maximum. There we go. Now, to go and find our median, we need to use that little formula we've been using for percentiles. Okay. So maybe I'll write in here L equals, and let's see what we have here. So we have N equals 501. That's how many people, or is this groups? Yeah, 501 groups that were studied. So 501 is N. And we're looking for the 50th percentile. So we want to put a 50 up here and a 100 down here. And let's see what we get. 501 times 0.5. So we get 250.5. So that means that when we go to find the median, we're actually going to be looking for the 251st number in the ordered data set. And while we're at it, why don't we just do this for at least this side calculation? Let's do this for also Q1 and Q3. There we go. And so Q1, right, is the 25th percentile. And Q3 is that 75th percentile. All right. And so for this one, I'm getting 125.25. So again, this was not a whole number, so we round up. So we're going to be looking for the 126th number to be our first quartile. And then finally, let's find the location of the third quartile. So 501 times 0.75. And so I'm getting 375.75. So again, not a whole number, so we'll round it up. So this will be 376. 376th number will be our third quartile. There we go. So with the way our data has been given to us, we could hypothetically make a huge list and count until we get to the 126th number, 251st number, and 376th number. That'd be a pain. So is what I'm going to have us do is record the cumulative frequency. Let's see. And let me add in some columns here. I might add in one more row to this. And I will. I'll call this last one locations. All right, there we go. So if we've just looked at the twos, we have a total of 254 numbers. Okay. But once we've looked at the twos and threes, we have a total of 254 plus 168. 254 plus 168. Let's just double check that. And yeah, we're getting 422. Now, if we make a list of the twos, threes, and fours, well, we'll have 254 plus 168 plus 52. So that gets us up to 474. If we made a list of numbers with the twos, the threes, the fours, and the fives, then we'd add 21 to this. And so our cumulative frequency now is 495. And then lastly, once we get over here to the sixes, we have six more numbers, and that should add up to our total, which is 501, and it does. So we have not made a mistake here. Now, in terms of the locations, this means that I'm going to write actually a little bit smaller so that I can write in a range of values. So the locations that contain the twos are going to be numbers 1 through 254. Okay. That means the threes are going to start at 255 and they're going to go up to this 422. Okay. And then the 423rd number is going to be the very first four. And that's going to go all the way up to the cumulative frequency, which is 474. Let me try to write that a little bit smaller. There we go. Okay. And then that means the 475th number would be the very first five. And then the fives should end at 495. And I don't think we have to go any further than that to identify all of these. So the 126th number is in here, meaning it's a, if I scroll up, it means it's a 2. So our first quartile is a 2. Our median, let's check out the median, should be the 251st number. The 251st number is also in here, um, which is also a 2. And then the third quartile, let's see what that is. The third quartile is the 376th number. Number 376 lies in here. It's a 3. And you can actually tell just by looking at the data set that this is heavily skewed to the right. But we'll be able to see that once we make the box plot as well. But something kind of strange did happen here. Our minimum, our first quartile, our median, and our third, yeah, our minimum, first quartile, and median are all the same number. So our box plot is going to look kind of strange here. And we only need to vary from 2 to 6 here. So yeah, this will be a strange box plot. There we go. So here's our number line. And I'm going to use actually a little bit bigger marker here. There we go. So this tick mark here will be at 2. And we just need to count by, let's just count by 1s to 6. There we go. So we have our number line. Let's put a mark in at 2. Okay. We'll also put one in at I guess the next thing, which is the third quartile, which is right here. We can also put in a mark at the maximum. So when this happens, we're still going to have a box here, but it does look quite a bit different. And it looks quite a bit different because this one spot here is the minimum, the first quartile, and it is also the median. Okay, so we kind of only have half of the box in some sense, but this would be our box plot here. Kind of strange. All right, well, let's go ahead and we'll scoot down and we'll take a look at another one. Okay. So here I'm going to have us looking at the interquartile range, and again, I want to point out that this interquartile range is a measure of spread, and it is considered resistant. And the range is another way to measure the spread of the data, a very reasonable way of measuring the spread, which is just the maximum value minus the minimum value. But it's not resistant to outliers, is the unfortunate part. And so, is what I'm going to have us do down here is it says, or let's read it, and then we'll figure out what we're going to do. It says people with diabetes must monitor and control their blood glucose level. The goal is to maintain fasting plasma glucose between about 190 and 130 milligrams per deciliter. A study planned to compare the effectiveness of group instruction versus individual instruction on diabetes control. Here are the fasting plasma glucose levels for 18 diabetic patients who were given group instruction and 16 diabetic patients who were given individual instruction 5 months after the end of the instruction. Okay. And we're going to use our TI 83 or 84 to find the 5 number summary for the two data sets. and to create the corresponding box plots. Okay. So go ahead and get your calculator out, and we're going to want to hit stat, enter on edit, arrow up, and clear out any data you have in your lists here. And I'm going to arrow left and then back up and clear out this list, arrow back down. And then we want to very carefully type in this data. Okay. So let's go ahead and do that here. And remember, after each number you type in, you want to hit enter. Right, and then we have another row below that. Now, even though it's not always exciting, I always recommend going through and actually double checking that you've typed this in right, because there's a lot of numbers here and it's extremely easy to make a typo. And so that's all I'm doing here is I'm just arrowing through this and making sure it matches what I have in the table above. There we go. And so now I'm going to arrow over. And so let's see, that was the control, or not the control group, the group instruction. So now we need to type in the data for the individual instruction here. And I will be double checking these as well. Just again, because it's just too easy to make a typo. And this also means anytime you're, taking a test, if you have time, double check that you type things into your calculator right. Let's see here. So now I just have a few more. 283, 226, 223. All right, now I really do need to go through and check these. Let's see. Okay. So now that we have that all in there, if we want to find the 5 number summary for each one of these, we can do it in 2 ways actually. One way is that we could actually go like this. We could hit stat. We could go over here to calc, and you can actually use this 2 variable statistics, because this can work with 2 lists at once. And it's just kind of a convenient way to do that really quickly here. So I'm going to arrow down here to 2 variable statistics and hit enter. Okay. If you're on a TI-83 or an older TI-84, you can actually just hit enter if you're not seeing the exact same screen as me. If you are seeing the same screen as me, you want your X list here to say L1, your Y list to say L2, because that was our second list. So I'm going to hit second and the number 2 to make L2 pop up. And then you can delete this frequency list here. We didn't have one. And so we'll hit calculate. Now it's telling me there's something wrong, and I know exactly what it is. I'm going to hit go to. The issue here is when you do use two variable statistics, it expects both those lists to be the same length. So actually, we're not going to be able to do it using that. We're going to have to use one variable statistic. So I'm going to hit stat. I'm going to arrow over to calc. I'm going to hit enter on one variable statistics instead. My list, I'm going to use list 1 first, and I'll switch this to L2 when I'm done. And I'm going to come down here and hit calculate. If you're on an 83 or an older 84, you can actually just hit enter and it will give you the one variable statistics for list 1. Okay, and we'll talk about what to do with list 2 here in a minute. Okay. So your 5-number summary, if you scroll down, it should be these last 5 numbers. So I'm just going to go ahead and copy them. So this was for the group instruction because that was the first list that we typed in here. So this should say instruction. And here in a second, we're going to do this for the individual instruction. And for those of you who are, again, on an older calculator than the one I'm using here, when you do see that one var stats pop up, and maybe I'll point out when here in a second, but we're going to want to use list 2 now. And so you do actually have to let your calculator know that you don't want to use the default, which is list 1. So you're going to have to follow this with an L2 like that. And so let's go ahead and give this a try here now. So I'm going to hit stat again. I'm going to arrow over to calc. I'm going to hit enter for one variable statistics, but this time I need to hit second in the number 2 so that I'm pulling from list 2. We have no frequency list, and we'll go ahead and we'll hit calculate, and there it is. But again, if the word one variable statistics pops up without the screen that you were all seeing a moment ago, just follow up by hitting second and the number 2 so you see a list 2 right after your one variable statistics, and you can hit enter. So let's go ahead and record these. Oh, and actually before I do screenshot those, let me arrow down so that I'm actually looking at the 5-number summary, which should be from here to here. So there's something else we can actually do here. So we can actually make the box plots on the calculator as well. So not only can we make these 5-number summaries, we can make the box plots. So since we already have the data in, all we really need to do is adjust our window before we hit graph. And we also need to turn some plots on. Okay. So let's do a few things. For one, I'm going to hit my y equals here, make sure that this is all blank. I don't want to see any lines or curves in addition to our box plots. The next thing is we actually want to hit second and then y equals. And you can see right above y equals, it actually says stat plot up there. And that is because if we want to make a statistics plot, we need to hit this button and turn the plots on. And you can see in 1, 2, 3, and 4 here, everything's off. So I'm going to hit enter on number 1 here. I'm going to hit enter on to turn it on. Now down here are a few options. Like this is going to be a scatter plot. That'll be a type of plot we're going to make in the near future. Here is a histogram. Okay. This is a modified box plot, which we'll talk about in the next video. And then this one right here is just the regular old box plot that we want. And so we're going to hit enter on that, arrow down. And I do want this to come from list one. And so you can see here, list one is going to be blue. And so blue will represent the um, group instruction. So next is what I want to do is I'm going to hit second and then y equals again. And I'm going to come down here and turn on a second plot. Okay, I'm going to hit enter here. Okay. I'm going to hit enter on. I'm going to arrow down and make sure that I have the box plot highlighted and hit enter. And then arrow down again. And if you don't have list two already here, remember just hit second and the number two. And so now in red, we'll have the individual instruction, and then we'll be able to compare these. So let's go ahead here and we can hit window now. So we need to know essentially what X values are we actually looking at here. So if we go back to our OneNote here, we can see that the smallest value between both data sets is 78. And the largest between both is 359. So one option here might be maybe we could go from say 0 to 400 might be one option. Okay. If we want to zoom in a little more, maybe we could start at 75 and maybe go up to 375 and maybe count by 25s. Why don't we do that? I'm going to go to 75 to 375. And I said I'll count by 25s here. Okay. Now, in the Y direction, this part actually you won't have to mess with when you're making a box plot. You can just leave that as is. Okay. And so all we have left to do here is to hit graph, and we can see both our box plots. And I'm going to copy those over. Um, and I'll show you another interesting feature though on the calculator that we can use maybe here in a minute. I think I'm going to paste this over here on the side. There we go. So one thing you can do when you're looking at these box plots is if you hit trace, you can see it already highlighted me on the median and it's telling me the median. And I can arrow over and it'll tell me the third quartile, arrow over again, and it'll tell me the max. If I arrow down, it'll put me on the red box plot. And I can arrow around on that one as well to see the quartiles, the median, the min, and the max. Okay. All right, so now over here, um, we can do a few things if we want to compare these. We can compare their where they're located in terms of like their center. Okay. So we could look at the median. Let me just scoot this up. Okay. So yeah, let's maybe do say that here. Let's say we're going to look at our measure of center. And right for this one, we have the median is 147.5. And for our measure of center over here, we have that the median is, all right, equal to 191.5. There we go. So if we're looking at the median, it looks like the individual instruction was a little less successful at keeping those blood glucose levels down or at a healthy range. So that's one thing we can note here. We could also look at the measure of spread, the IQR. So the IQR is just supposed to be Q3 minus Q1. So I'd take that 172 and subtract 112. So if I hit quit, 172 minus 112. And I want to double check that before I hit enter here. Yeah, 172 minus 78. So I'm getting 60. So the middle 60, or sorry, the middle 50% of the data is all within 60 units. Okay. And if we were to talk about the measure of spread over here, so for the middle 50% of the data, this time our third quartile is 222. Let me type that in first. 222 minus, and let's see what that first quartile was. 159.9, 159.5, I believe. 159.5. Yeah, good. So for this one, I'm getting an IQR of 62.5. So these both have a very similar IQR, but again, very different medians here. So that's one thing to note. If we come over here, it does seem that um, let's actually label these. I'm going to label this as the, what was this? This was the group instruction. And the one in the red here, this was the individual. Maybe to keep it short, I'll get rid of the word instruction there. There we go. Okay. You can see, though, the last 25% for the group instruction, it is spread out very far. So that is kind of an interesting feature there as well. Okay. I'm noticing that between these two, the person that had the lowest blood sugar was in the group instruction. Now, I don't know if that was within a healthy range. Let's kind of maybe look at what it said a healthy range would be here, between 90 and 130. Okay. So we were counting from 75, right? So this was 75. This is 100. This is 125. So basically, the healthy range is mostly actually right in here. Okay. And you can see that almost no one in the individual group was in that healthy range. Versus, we did have a good chunk over here that seems to be close or within that healthy range. So again, the evidence is kind of piling up here that the group instruction was better. Okay? If we really wanted to draw some conclusions here, we'd probably want to do some further studies to verify this. Well, that's it for this example. Let's see if we have anything else here. Okay. So here we have box plots and histograms, and I just want you all to see how they compare, because when we do make a box plot, we are looking at a quantitative variable, just like when we make a histogram. Okay. And so if I zoom us in, well, you can see that this graph here is approximately symmetric. Okay. And if you look at this box plot here also looks approximately symmetric. And the reason I say that is, like, for instance, this quarter and this quarter look about the same, and these outer quarters look about the same. So it seems very symmetric. And when I say the same, I mean about the same length. Skewed right. Okay. So again, that last 25% of the data, I don't know exactly what it is, maybe somewhere in one of those last three circles is probably about the last 25%. And you can see here that our last 25% is more spread out than the first 25% or the next 25% or the next 25%. It's that last one that's spread out the most. And that is what's going on here. Okay. In fact, we probably have our first 25% somewhere in here, our next one here, another one in here, and then our last bit here. So this kind of adds up. If you wanted to be really careful, you actually could figure out exactly where the 25th percentile would be, or approximately where it would be, approximately where the median would be, approximately where the third quartile would be, based on your histogram. And you could actually be a little more sure that these two match. But you don't generally need to do that. And then lastly here, again, we have a lot of data grouped up in one spot. And you can see that we have the same thing happening over here on the right of our box plot. That little slice here represents 25% of the data. So there's a lot crammed in that one spot. Yeah. And again, these two extra long sections are kind of showing me that this is skewed to the left, which is what we're seeing over here as well. And so is what I'd like us to do is on this next one, go ahead and pause the video and see if you can match these up. There we go. All right. So I'm going to really use kind of the same strategy. I'm going to just really look at the skewness or the symmetry. Okay. This one appears to be the closest to symmetric. I probably wouldn't call this one approximately symmetric, but it's close to being approximately symmetric. And same with this box plot here. The two middle quarters look about the same width, and the outer quarters look about the same width. So I would have here that, let's go like this. These two match here. Okay. This one over here seems to be skewed to the left, okay, which means we should have a lot of data packed in on the right end, and then the left end should look more spread out. Okay. And between these two, this one seems like the data is much more compact on the right because that quarter and the quarter to the right of it are fairly small. Okay. And then this quarter should be the spread out one, and you can see that this is pretty spread out. Okay. So I'd match these. Okay, which technically tells us 3 should go with A. But again, you can see a lot of data packed up here on the left, and we have a lot of data on the left-hand side here. And so let's match those. All right, and so we have them matched. And that wraps up the 5-number summary and box plots. Is what we'll cover in the next video. Is we'll look at how to identify suspected outliers using the 1.5 IQR rule, and we'll look at modified box plots.